Hello everyone. Today I'm going to give you all the tools you need to write any set in interval notation. So let me tell you the key players in this. We are going to use brackets and parentheses. So we're going to use a left bracket, a right bracket, a left parenthesis, and a right parenthesis. And we're also going to be using commas and unions. So let me tell you about the brackets and when you need to use them. And we're going to do a lot of examples where you're going to see how to use them. So brackets are used when we can equal a number. Parentheses are used when we cannot equal a number. And this U is a union, which is exactly what the word means. We put two things together. So a union is used when we want to join two sets. We're going to see each one of these, so the brackets, the parentheses, and the union in some of the examples. We're going to do a lot of examples, so I'll make sure that you understand how to write any set in interval notation. Let's start with this first set. Here I have all the numbers, all the real numbers between -3 and 4. This inequality is less than or equal to. And this one is also less than or equal to. Notice that when we have equal to, that means we can be this number. And here I have an equal sign, so we can be this number. So anything between -3 and 4. How do we write this in interval notation? So what you're going to do is you're going to put a number, comma, another number. And the number on the left is the smallest number you can be. And the number on the right is the biggest number you can be. Here you see that the smallest number I can be is a -3. So I'm going to put -3 here. And the biggest number I can be is a 4. Okay? Now, if I can equal those numbers, which I can because I have an equal sign here, I use brackets. So over here I'm going to use a left bracket, and on this side I'm going to use a right bracket. Okay, so this is the interval notation of all the x's between -3 and 4 and can equal -3 and 4. I'm going to change this a little bit. This time, I still have the less than or equal to sign here. But here I just have the less than sign. So this is saying x can be any number between -3 and 4. It cannot equal -3, and it can equal 4. So I'm going to do exactly the same thing I did before, which was I put a comma, and I put the smallest number I can be on the left, and the biggest number I can be on the right. Well, the biggest number I can be is 4, and I can equal 4. The smallest number I can get really, really close to -3. So I'm going to put a -3 here, but I cannot equal -3. So I use a parenthesis here. And that's the interval notation. Let's try another one. You see how I moved the equal sign here and took it away here? Let's see if we can write this in interval notation. So I put the smallest number I can be, which is -3, comma, the biggest number. I can equal -3, but I can't equal 4. So I use the parenthesis here and the bracket here. Now here I deleted the equal sign for both of them. So the interval notation here is -3, comma 4, and I use parentheses on both sides here because I cannot equal these two numbers. Okay, how about pause the video and see if you can write this set in interval notation. All right, so the smallest number I can be is 7, comma, the biggest number I can be is 13. I can equal 7 because I have this equal sign, and I cannot equal 13. Let's try x greater than 3. So notice that I'm just using greater than. I cannot equal 3. So we're going to do the same thing. We're going to put a comma, and we're going to put the smallest number we can be on this side and the biggest number we can be on this side. So the smallest number I can be is anything really, really close to 3, because 4 is greater than 3, 3.1 is greater than 3, 3.00001 is greater than 3. I can get really close to 3, but I cannot equal 3, so I put a parenthesis. But here, my upper limit, I don't have an upper limit, right? I can go to 4, 5, 6, a million is greater than 3, 2 million is greater than 3. So we go out to infinity. Okay? Now we have to figure out what kind of sign, like a parentheses here or a bracket. Turns out that we're going to use parentheses whenever we see an infinity sign. So if you have infinity, you use a parenthesis. So it's either this one or this one. It depends on if the infinity is on this side, which you'll use negative infinity here, and you'll put a parenthesis here. And if it's on this side, you're going to use this one. So if you have infinity, you're going to use this guy. And if you have negative infinity, you're going to use this parenthesis, because it's always going to be on the left. And the reason why we can't equal infinity is a concept, it's not really a number. So that's what you want to think about. I can't really stop on a number, because you could think of it, this is like negative 1 billion. Or sorry, not negative, positive 1 billion. But then there's 1 billion and 1. And there's always a larger number. So this is a concept, and we have to put a parenthesis here. Let's try another one. Here I have x is greater than or equal to 3. So what do you think is going to change compared to this one? It's going to be exactly the same thing, except I'm going to change this to a bracket because we can equal 3. So this is going to be 3 to infinity, parentheses here. Let's try this one. X is less than negative 2. So we can't equal negative 2. So we start with our smallest number, put it here, put our largest number here. Okay. Negative 5 is less than negative 2. Negative 10 is less than negative 2. This is going to go out to negative infinity. And then the biggest number we can be is negative 2, but we can't equal that number. So we're going to put parentheses around both of these. When we see infinity, we always use a parenthesis. And when we see this negative 2, because we have this less than sign, we use a parenthesis. And that's the interval notation. All right, x is less than or equal to negative 2. Maybe pause the video and write what you think the interval notation is. The interval notation is negative infinity to negative 2, bracket. All right, the next set is all real numbers except the number 8. This is where we're going to use a union sign. We're going to do exactly the same thing we did before. Now, if this problem had said all real numbers, let me tell you what that's going to look like. All real numbers would be negative infinity to positive infinity. So I want to take this set and I want to delete the number 8. So what I'm going to do is I'm going to start with the smallest number I can be, which is negative infinity, and then I'm going to move up. So I go from negative infinity, let's say like negative 1 million, then we can go all the way to negative 1,000, negative 100. We have 0, 1, 2, 3, 4, 5, 6, 7. So we're thinking of the largest interval we can make without having to take anything out. Then we go up to 8. And then at 8, we cannot equal 8, so we put a parenthesis here. Then we use a union, and then we say 8 to positive infinity. So the smallest number being 8 to positive infinity. So this is like saying we're going from negative infinity all the way to 8. We jump and go to infinity. So we're taking out this 8. Let's try a more complicated example. All real numbers except 5 and 2. Remember that all real numbers is negative infinity to positive infinity. So we need to take these 2 out. I'm going to put them in, going from lowest to highest. So 2 is first and then 5. So what we're going to do is we're going to go from negative infinity, then we move up to the biggest number we can be without making a jump. Well, we can get all the way to 2, but we can't equal 2. Then we make a jump, then we go to 2 to 5. So we can be any number between 2 and 5, but we can't be 2 and we can't be 5. We make a jump, and then we go from 5 to infinity. A mistake I see a lot of students do is that they forget this piece right here. They'll just say negative infinity to 2, union 5 to infinity. And that's not correct, because then you're missing all the numbers between 2 and 5. Like 3 is a real number that's not 2 or 5. But when you say negative infinity to 2 and then 5 to infinity, you don't include 3. So you need this middle piece. Okay, let's see if you can do this. Pause the video and see if you can write all real numbers except negative 5, 3, 0, and negative 10. I'm going to put these numbers from smallest to biggest. So negative 10, negative 5, 0, 3. I'm going to start with negative infinity. I'm going to go up to the smallest number I have to take out, which is negative 10. Union, I go from negative 10 to negative 5. I can be any number in between those. Union, negative 5 to 0. Union, 0 to 3. Union, 3 to infinity. Let me make this a little bit smaller for you so you can see it all on one screen here. Another way to remember this maybe is to say, whenever I use a union, I always have to have that same number on both sides of that union, okay? Negative 5's here and here, 0 and 3. So when we have 1, 2, 3, 4 numbers we take out, we're going to have 1, 2, 3, 4, 5 intervals. The last problem we had 2 numbers we took out and we had 3 intervals. So it's always one more interval than the amount of numbers you have to take out. Okay, let's try something else. This is a little more complicated. We want x to be greater than 7 and x not equal to 12. So let's write both of these intervals. X greater than 7. That means if it was just this piece here and I didn't have this, I would say this is 7, but without the bracket, it would actually be a parentheses here. 7 to infinity, right? If this piece wasn't here, we'd go from 7 to infinity, because anything greater than 7, we don't have an upper limit. But we need to take out this number 12. So we can be any number from 7 to infinity except the number 12. So we have to add this piece. So what would I have to change here? I would have to go from 7 to 12, union 12 to infinity. And that is the interval notation. Okay, we're getting more complicated. Here I have that x is less than or equal to 1, x is not 5, x is not negative 5, and x is not 0. Let's see if we can put this in the interval notation. I'm going to start with this piece. How would I just write this piece? X is less than or equal to 1. Well, I'm not going to have a lower bound, so I'm going to go to negative infinity, parentheses, comma, 1, and because I can equal 1, I'm going to put a bracket here. Now I've taken care of this piece, now I need to take care of these three pieces. I need to get rid of 5 in this interval. Well, notice that 5 isn't in this interval, right? It's just negative numbers, and then you go to 0, and then anything between 0 and 1. So this piece isn't even in here, so I don't have to worry about it. This number, negative 5, is in this interval, and I have to take it out. At the same time, I have to take the number 0 out because it is in this interval. And remember to put them in order. Negative 5, you have to take out first, and then 0. So this will be negative infinity. We go up to negative 5. We can't equal negative 5, so we make a jump. Then go up to 0, make a jump, and then go from 0 to 1, and we can equal 1 because I have this bracket here. And so that's the interval notation. All right, let's try this one. X is greater than or equal to negative 10, and at the same time, we want x to be less than 3. Let's put both of these in interval notation and then see if we can combine them. So for this one, x is greater than negative 10 or equal to negative 10. So the smallest number we can be is negative 10, and we can equal that number, so I put a bracket, comma, infinity. That goes with this one. But at the same time, let's do this one in red. X has to be less than 3. So the biggest number we can be but not equal is 3. We go to negative infinity to 3. So we want to find the intersection. We have the word and here, and this is the intersection. It might be easy to draw a number line to help you find the intersection. So let's put these two numbers, negative 10 and 3, on the number line. You can even put some numbers in between them. So you want to see where you're living in both of these sets. So negative 10 to infinity, we got a colored dot here. That means that we can equal this number. This goes this way. I'm going to put this one in blue. This one says negative infinity to 3, but I can't equal 3, so I'm going to put an open circle there. And I want to see where I'm living in both sets, where I'm both green and I'm blue. And notice I'm green at negative 10, and I'm also blue at negative 10. I can equal that number. So the lowest number, because anything past here isn't green, is negative 10. And the biggest number, well, we're in green and blue here, but we stop at 3. But 3 is not colored in. It's colored in when it comes to green, but remember, we have to be colored in with green and blue. So we use a parenthesis here. So you see, this is the intersection. This is the last problem I have for you. Oops. Here I have that x is greater than 7 or x is less than or equal to negative 3. Okay, I'm going to do the interval notation for both of these. X is greater than 7. Well, that means we can't equal 7, but we can be anything bigger than 7. So 7 to infinity, parentheses, parentheses, or, the word or is union. The word and is intersection. And here we have anything less than or equal to negative 3, So the interval notation looks like this. And we want to take the union of these two. So we can be in both of these sets. So we're taking the union, but when we write something in interval notation, we start with the smallest number, and then we go up. Notice that we have to change the orders of these intervals, because negative infinity should be over here. So then negative infinity to -3, bracket, union 7 to infinity is going to be the interval notation.